Hello everyone, this is Aurora with the Central Coast Astronomical Society, and I am here with Kent Wallace, one of our astronomers from our club, and we are going to take you on a tour of the night sky with that has to do with objects you can see with binoculars and telescopes that are themed with Halloween. So this is a special presentation that we put together for you, and what's really cool is it's got a handout of many objects, and we're going to be going through the first 13. Is that right, Kent?
Yeah, that's the devil's dozen. Figure it fit for Halloween.
Or the deep sky dozen that we're going to be going through. And so a lot of these objects you will be able to see with binoculars, telescopes, actually I think just about all of them. And not all of them are going to be up tonight, meaning October. And so these are objects that if you can't see tonight, just put them on your list and for a future date, but it's just something that we thought would be really fun for you to take a look at. Some of the objects are going to be southern hemisphere as well, so if you live down in the southern hemisphere, you're in luck. We have a few objects for you as well. All right, Kent, you ready to get started?
Sure.
All right. So the first thing we wanted to talk about, Kent, do you want to talk a little bit about Mars and what's so great about it now, October of 2020?
Oh yeah, Mars is having its closest approach. I think it was closest on the 6th, and it's quite bright. Bright. It looks brighter than Jupiter's big reddish orange star, kind of spooky star for Halloween. It is. And it reaches opposition, I believe, which means it's, directly between, or actually we're lined up with the Sun, the Earth, and then Mars in a straight line on the 13th, which is another good Halloween number. And so Mars, is really a good one for Halloween.
Definitely. And it's something that you can see even just naked eye. It's going to look really bright. It's actually going to outshine Jupiter right now this first week or two in October. But it's going to be super bright in the eastern sky, and it's going to slowly progress as we move on through time.
Another thing, if you have like a 6-inch to 8-inch telescope, you should be able to see detail if the scene's good, which would be dark marks or maybe the ice cap. And so those are some of the things you should pick up as long as your scene is decent. Yes,
awesome. Okay, so that's going to be one that you can look at tonight with binoculars, telescopes, as Kent mentioned, or just naked eye. Okay, so the first one of our deep sky objects we're going to take a look at is the Witch Head Nebula. You ready? Okay, so this is the object we're going to be looking for. Let me show you first, before Kent goes to talk about it too much, let me show you first where it is in the Stellarium program. Now, if you've never seen this is a planetarium software, you can download it for free from Stellarium. Super easy to use. You just put your zip code in and it adjusts what it shows you in the night sky. Now remember, some of these objects like this one's not going to be visible tonight unless, even if you stay up really late. Is it visible at all?
Yeah. If you get up early in the morning, actually Orion is nice and high in the sky about 5 o'clock in the morning.
All right.
So it is, we're heading towards winter. So if you get up early, you can see Orion up there. You can see Rigel, which is the star that lights up the Witch's Head Nebula.
All right. So in order to find this one, you're going to find Orion. And as you can see, Orion is a little bit hard to find. But if you look for those 3 belt stars and then those sword stars, and then we connect the dots, we're going to see the constellation of Orion. And by his foot, Rigel, this is where we're going to be focusing right in here. So what are we going to see in here, Kent?
Okay, Rigel is a blue supergiant, and it's lighting up the Reflection Nebula, which is the Witch's Head Nebula. And it's in another constellation. It's Eridanus, which means the river. It's a great big, long constellation. It goes all the way down towards the Small Magellanic Cloud area of the sky. So it's a really long, in fact you can see it there on the image how long that Eridanus is. And it's got a star at the very end, I think called Arcanar or something like that. I'm butchering the pronunciation.
No, you got it. You got it. Let's see if I can actually get it here. Yep, you got it. Achemar, or NAR.
Yeah, it's not that far from the the small Magellanic Cloud, but it's way down south.
Yes,
But
it
anyhow,
is.
the Witch's Head is interesting because if you have dark skies and it's up nice and high, you may be able to see it in binoculars. It's one of those things where people thought that, oh, it's in a photo, you'll never be able to see it. But there's been several instances where people use either a small telescope at low powers or binoculars. The important thing is having the wide field, and there's been reports that they've picked it up. And so that's the one nice thing. There's been some confusion about it. It's given an NGC number 1909, and for a while they thought it didn't exist because William Herschel, he messed up the direction. He said it was following Rigel rather than preceding Rigel. And so they were looking on the other side of Rigel to try and find this large diffuse nebula, and in fact it's on the other side. And so they thought NGC 1909 didn't exist, and they gave it an IC number, which is a later number for the index catalog, a 2118 number. But it's pretty well known as the Witch's Head Nebula. And in fact, you can see the APOD image there. It has the same problem William Herschel had. They flipped the negative. It should be on the other side. And so left and right are reversed on that that image, but it's still a really nice image, and that really nice bright star, that's Rigel there. It's about 900 light years away, and William Herschel discovered it on December 20th, 1786. It's about, let's see, it's 2.4 degrees up and down, or north and south, and about 1 degree wide east and west. So it's a big object. That's why you need binoculars or a telescope, a small telescope at low power to give you a really big field, and then you can pull it in. And let's see, the IC number is from a photograph taken from Max Wolf in 1909. He did a lot of, when they first started attaching cameras to telescope and got good enough film where they could start taking decent pictures, they started finding a lot of nebula, and those ended up in the index catalog, or the IC numbers for the new general catalog. Does that kind of make sense? Or?
Yeah.
And
awesome.
So I've never tried it myself with binoculars. I'm tempted to do that, to see if I can pull it in with my old 750s.
Wow. All right. Do you want to go to number 2? We have.
Yeah, let's go to number 2. That's a good scary one. You can see the two kind of eyes there, the bright white areas. That's the Ghost Head Nebula. And it's in the Large Magellanic Cloud, kind of below the Tarantula Nebula. It's in the constellation of Dorado, the swordfish, and we're talking way down south. The Large Magellanic Cloud is closer to the South Pole than the Big Dipper is to the North Pole. So it's way down there south. Magellanic Clouds are wonderful. The Large Magellanic Cloud, you don't star hop. You nebula and cluster hop to get to where you're going, because there's so many nebulas, open clusters and nebulas piled in that glowing area. Also, that area is naked eye. You can see it quite well. Not the Ghost Head, but the Large Magellanic Cloud. In fact, I can see the Tarantula Nebula in the image there, which is that brighter, larger area. And it kind of shines out first after the sun goes down and it's getting dark. You can see the old Tarantula Nebula there. But the Ghost Head is given an NGC number. It's NGC 2080. It's an emissions nebula. The Large Magellanic Cloud is about 163,000 light years away. So the Ghost Head Nebula would be about 50 light years across at that distance. It was discovered by John Herschel on December 23rd, 1834. And it can be seen in a 12-inch telescope as a bright nebula. So an 8-inch scope would pull it in quite well. Of course, down there the seasons are reversed, so instead of being in cold weather, John Herschel was in dead summer when he found that object.
Awesome. Now, should we go back to the witch and maybe check out her broom?
Oh yeah. Let's go back to the Witch's Broom Nebula, and that's on the western side of the Veil Nebula, which is a supernova remnant in Cygnus. And that one is real easy because there's a nice bright star next to it. It's called 52 Cygnus. It's a naked eye star around the 4th magnitude. And you can look up and see 52 Cygnus, and the Witch's Broom runs right past it. So I usually just put my telescope on. There, you got it. You can see that bright star in the Witch's Broom area there. It's also given an NGC number. It's NGC 6960. Mm-hmm. Yeah, and that star there, that 52 Cygnus, that's a naked eye star. So it makes it real easy. You find that star, you just put your telescope on it, and then go up and down, back and forth to see how much you can see of the Witch's Broom. That is a pretty nice image. That may be a Hubble image. I don't know.
Yeah.
It shows a lot of filaments, a lot of detail.
Mm-hmm. Yeah, it certainly does. Now, originally when I called up the Bat Nebula, you said it didn't look evil enough. So we actually went back and found a better image of it, didn't we?
Yeah, I found a very evil-looking. This is on the other side of the Veil Nebula. Mm-hmm. This is on the eastern side of the Veil Nebula. And it was such a evil-looking bat. You know, you can see its eyes up there and a wide open mouth, ready to bite something. And so, and the nice thing is, it's not that far from the Witch's Broom. And so, maybe the witch is trying to hit the bat with her broom. Who knows? But it's given its own NGC number. It's NGC.
Wait, this isn't the Bat Nebula. I'm showing something.
That's a planetary nebula you got there.
That's not the right one.
Oh, you know what the problem is that for some reason someone called that the Bat Nebula.
Yeah, and that can happen. Yeah. So in Stellarium. So here, let's go back to the Veil.
I can give you the number for the part of the bat is 6995.
Here. This is where we're looking right here.
6995. Yeah, and that's also called the Network Nebula. And that bigger chunk down towards the bottom there, that's where the bat is. In my 20-inch scope with using the 32 millimeter eyepiece, which is a 2-inch eyepiece with a 2-inch O3 filter screwed into the base of the eyepiece, that looks fantastic. There's I call it an egg crate pattern. You can see all these square areas, and it's fantastic view in the 20-inch. Really pulls in a lot of filaments. Mm-hmm. And so, you can kind of see that rectangle there that's kind of like a wide open mouth on the bat.
Yeah. Would you use any particular filter if you were looking through your scope?
Pardon, what was that?
Would you use any particular filters for this one?
O3 would be a good filter. Also, UHC would work good. Okay. It would really enhance the view. Although you can see it in an 8-inch. In fact, some people have seen that section, what they call the Network Nebula, in binoculars.
Really?
So, yeah. Some people pulled it in. You got to wait till it gets up nice and high. Got to be in a dark area, and you can pull it in with binoculars. Which, again, I've never tried, but That's what they say. So,
That's awesome.
I wanted to mention this applies to the witch's broom also. That supernova remnant's 1,400 light years away. So that's the distance of it. Was found by John Herschel on September 7th, 1825, where the witch's broom was found by his father, William Herschel, on same day, September 7th, but in 1784. So that's kind of coincident. He found it like, about 40 years later, 41 years later, on the same date. So that's kind of cool.
Wow. That's cool. All right. Let's see. I kind of was alluding to the next thing you want to take a look at. Do you want to look at the cat? Let's change gears to a kitty cat.
The cat's paw nebula.
Cat's paw nebula. Doesn't it look like a cat's paw? Look at that.
That's actually missing a toe, but it's close enough. The brightest toe there is given an NGC number.
Okay.
It's NGC 6334, but the whole area is actually, the whole paw is RCW 127. And for the life of me, I can't remember what RCW stands for. But it's in Scorpius. It's a faint emissions nebula about 5,500 light years away. The toe, I think, is around magnitude 9, and that whole area is about 40 by 30 minutes, so it's good size. It was discovered by John Herschel on June 7th, 1837.
How's
there. I can see Scorpius, I can see the stinger, and it's
there
right above
the
stinger. There
so tell us about this one.
Okay, and this is about, you see the stinger there, and you can see where the nebula is. Distance-wise, it's about 3 degrees west and 1 degree north of the stinger. And so it's over and it's up a bit to get to the cat's paw there. And so that's something for where to find it. Also, an O3 filter or a UHC filter should enhance the cat's paw there. But
awesome.
It's a relatively dim thing. I mean, if you get anything, you're doing pretty good. But it's had the cat's paw nebula name for a long time. Because photographically, yeah, it's missing a toe, but it still kind of looks like a paw print.
So how about NGC 6543?
Okay, yeah, my favorite planetary nebula.
Is this your favorite?
Nebula.
Let's see if I've got the right one.
And you got the central area of it there. They blow it. Yeah, they can show the outer envelope
of
the Cat's Eye Nebula.
So we're looking in Draco?
It's NGC 6543. So that's real easy to remember.
It is easy to remember. It is. And so this one is going to be in Draco. You got it.
Yeah, it's above the back of Draco the Dragon.
Okay.
And so I usually start at, there's a pair of stars off to the left that I usually start at, and then go kind of over the back to try and pick up the pattern to get to the cat's eye there.
Yeah, okay. And should we talk about what we would see there with a telescope?
Okay, in a telescope, 8-inch at low power, it looks like a green star to me. Some people might see blue, some people might see turquoise. And if you up the power, you can get a little disc. Now, my 20-inch, it's a whole different story. You can see a nice disc. The color is a lot brighter. And you can see the central star, which to me looks kind of a yellowish color. And that central star is only the size of the Earth. So it's enormously bright to cause that whole nebula to fluoresce.
Wow.
And distance-wise, it's about 3,000 light years away. The central area has a size of roughly about 22 arc seconds by 18 arc seconds. And it was originally, I believe, discovered by William Herschel, on February 15th, 1786. So William found it. And the interesting thing, it's really important for astrophysics. It was the first object that William Huggins directed a telescope with a spectroscope attached to it. And he saw a single bright line, where normally if you look at a star, you get a continuous spectrum spread out with maybe some dark lines in it. And that told him that it wasn't made of stars, it was made of a gas, or a low pressure gas, but it was actually gaseous. And so that kind of gave them a tool that they could tell, is it a gas or is it a bunch of stars clustered together that are extremely long distance away? And so this one I really love. It looks like it wants to eat that little galaxy in front there. It's showing the full outer halo around the central cat's eye that you normally see. There's actually a little bright area to the right of the central area that's kind of elongated, and that was classified as a galaxy by Barnard years ago. And you can actually, under really good conditions, you can see that with a filter in an 8-inch. Now remember, there was a guy that had a 20-inch scope that he put black felt all on the inside, and he was up at Mount Pinos, which is like 8,400 feet up, and he could see all the little flecks of halo around the central part of the cat's eye, which was really mind-blowing.
Wow.
And so the cat's eye, I look at that and it looks like some critter that's going to go after that little galaxy there. And so that's that image was, I thought, a really good image on Astronomy.
That is an image. Now, by the way, we did put the dates of the images in this handout I think for most of them, where you can actually find that image that we've shown in the handout. So you can look at that yourself on the screen if you like. Okay, who's next?
It's always nice to look at it like that. Let's see, you want to go to the Owl Nebula next?
Yeah, let's go visit an owl.
There's the old owl, and the cool thing in that image is you see the central star there, and there's two patches on either side. And that kind of, I think it's, William Parsons, who was the 3rd Earl of Rose in Scotland. He had the Leviathan of Parsonstown. He was the guy that gave the name, the Owl Nebula, to that planetary nebula. And it's just below the bowl of the Dipper. You see it's not far away from the bottom of the bowl. And that one, it was actually discovered by William Herschel on October 18th, 1787. And, oh no, I got it wrong. It's a Messier object. It's M97.
Yes.
It was discovered by Pierre Mersenne on March 24th, 1781. And, Lord Rose was the guy that gave it the nickname the Owl Nebula. It's magnitude 9.8. There's no problem finding it in a 6-inch telescope. It pops in fairly well. If you have an O3 filter or a UHD filter, it'll really pop out. And so,
nice.
That's a nice image there.
Okay, and then the owl cluster. I'm sorry. Go ahead.
Yeah, the owl cluster's next, and the Devil's Dozen line up there, and that's a really nice picture of the owl cluster. You can see it with binoculars. It really looks nice in a scope because of the stick figure. You got the little wings kind of going up. You got a long body. You got the two bright eyes. it kind of looks like an owl, a stick figure owl to me. It's also called NGC 457. It's an open cluster that's in Cassiopeia. And it's magnitude 6.4, so it's fairly bright. It's about 79,000 light years away.
Oh, he's upside down
go.
here. We have eyeballs here, and the wings are here.
The owl's upside down in that. He's flying upside down. And the nice thing about my scope is everything's upside down, so it puts him right side up in my scope. And so that's the one nice thing about having a reflector. And that one was discovered by William Herschel on October 18th, 1787. The name owl cluster was coined by David J. Eicher, I guess is how you pronounce his name. I've got several of his books, and he's current editor of Astronomy magazine.
Wow.
And so he's been in the hobby. In fact, he started Deep Sky Monthly magazine back when he was a kid. His father would help him make the Xerox copies that he'd send off to people that had a subscription. And later on, it became Deep Sky Quarterly, which was a glossy, really nice magazine. It ran, I think, about, was it like 40 or 50 issues before the Astronomy magazine company decided to kill it off, unfortunately. But I gathered up all the quarterly ones and also glommed onto any of the monthly ones that I could get my hands on. And so, his writings are really good.
Wow.
But anyhow, I've got off on a tangent there, but
no, that's okay. That's okay.
Currently he's editor of Astronomy magazine. The two big magazines that we all get are Astronomy magazine and Sky and Telescope magazine. And I subscribe to both, even though there's a lot of duplication. They still have individual articles that are really good.
Well, that's good to know. It's a good resource. All right, we've got
I guess we should go on to the
we've got 4 or 5 left. Do you want to do some skulls now?
Yeah, let's go for the Flaming Skull Nebula.
Now, if you're using Stellarium, you will not be able to find this one because it's not in the database. But if you put in there 59 SER, you will get real close to it, right?
Yeah, it's about a minute away, somewhat real close.
It's like right in there. If you want to see how to do this on the program, let me show you. You open up the search window and then you put in a position. And so I've got mine set to equatorial. And so in here, Kent gave me the position information. It's 18 hours, 24 minutes, 58.4 seconds. 58.4 seconds, that's the right ascension information. And then the declination is 0. And then 51 minutes and 37 seconds. Let's see if I can do this. 37 seconds.
Yeah, that should be plus 0.
Yes, it's plus 0. Yes, thank you. Plus 0, 51 minutes, 37 seconds. Okay. So you can see here's 59 serpens, and here is the position I just put in.
Yeah, it's about 52 arc minutes northwest of 59 serpents. And I have seen that at my 20-inch scope. It's not an easy object, but the images on the internet are really cool.
Yes, they are. Let me show one. How about there? Doesn't that look like a flaming skull?
Yeah, that's a good one. I like how the flames are going off the head.
This was taken by a professor.
Big white house. There's one star that makes up the eye.
That's true. It looks like he's got an eyeball right there. This was taken from a professor from the University of Anchorage.
And it's a good size object. It's 375 arc seconds by 302 arc seconds. So that's pretty good size. Would be about 5 minutes by 5 minutes, roughly. And so it's really a good size object, but it's faint. I put it in on the 20-inch, but I don't think I tried on the 8-inch.
Mm-hmm.
But the image was really cool there, so
Yes, it is.
I thought that was a good one for Halloween.
It is a good Halloween one. So again, it's right here. If you just look, well, here, let me back up a little bit. So if you are familiar with Aquila or Scutum or Scutum, you're going to be looking right about there.
There,
Can
yeah.
you see it?
And that's in Serpens, the eastern part of Serpens.
Yeah.
Serpens, what do they say? Yeah, Caudia, which is a snake's tail, or the eastern part of the snake. It's like the only constellation that's broken up into two pieces. Ophiuchus is holding one part, the head of the snake, or the western part, in his hands, and then on the other side of Ophiuchus, you've got the eastern part. So it's the only constellation that's broken up into two chunks.
Yeah, let me
All
see
the
if I can
rest
get
of
that
them
up
are
here.
intact.
Here's Ophiuchus. Okay, good. All right, let's go ahead. And what is our next target?
Okay, we've got the Skull Nebula, which is NGC 246. Really interesting planetary nebula. It's in Cetus, the whale, or also it's called the Monster. In my 20-inch, this is good size. It's about 240 by 210 arc seconds. To me, I can see an envelope with some stars inside. It looks more like a grape than it does the photograph there with this, the actual kind of skull-looking object. It's about 1,500 light years away. And in fact, we'll cover this again in our October talk. It's one of the objects that's in the October talk. And it was, again, discovered by William Herschel on November 27th, 1785. And, NGC 246 is a good number to trace it down with. It's about 6 degrees north of Beta Ceti, which is actually the really bright star that you see in Cetus the whale.
Oh,
and
there we go.
Yeah, let's see if they show the Beta Cetus is maybe that's that bright star it's showing over there. But I've got about 6 degrees north, so this thing isn't a line straight up and south, or north and south then. But also you can see those two stars to the, there's one star just over to the left and one star almost above it. Those two stars can be used, they form like an equilateral triangle with 246.
These two here?
One of them is Phi 1 or 17 Ceti. The other one is Phi 2 or 19 Ceti. So you can use those two stars to center in on an equilateral triangle. They are actually aligned horizontally in the sky. So I don't know why they're aligned at an angle, but it's probably how the program's set up.
Nice.
And you just kind of go straight south below those two stars, 17 and 19, and you'll hit 246.
Okay,
Does that make sense, Aurora?
Yep, that makes absolute sense. That looks great. And then you get to see something not quite as crisp as this picture, but you will see a fuzzy patch.
Filter really helps, but I've seen it in my 8-inch. So an 8-inch you can pull in it. Actually, it looks like a kind of like a hazy disc with stars embedded in an 8-inch.
Nice. Now, how about this one?
Yeah, the vampire star.
Vampire star. This is one that's not going to be. Well, if you want to search for it in Stellarium, it's not. You can't put in vampire star. You have to put in something else. What was the name of the star you were talking about?
Oh, Heinz Crimson Star. It's actually R. Leporis. It's a variable star, but R. Leporis might get it for you. It's in Lepus, the rabbit,
There it is.
and it's a long period variable carbon star. It
And it's a
varies
different
from
color. Look
magnitude
at that.
5 point. Well, pardon?
It's a different color. Look at that.
Yeah, I can see some color there. It actually gets as bright as 5.5. So it, you know, for a little while there, it's naked eye. Then it, drops down as low as 11.7. It takes 432 days on average for it to cycle from brightest to dimmest and back to brightest again. It's about 1,360 light years away. And I think the reason they called it the vampire star on APOD is I've seen it where it looks like a drop of blood on a black sky. I mean, super, super red color. And so I'm sure it varies a bit in color over time. But I caught it out there one night. It was just beautiful. Had other guys there, and we were all looking at our Leporus. So they called it the vampire star. And I noticed the APOD is October 31st for 2018. So definitely a Halloween name that they put on there.
That's awesome. All right.
And that's up that's up. If you want to stay up late, the winter constellations are coming up, and the Lepus the rabbit is just under Orion. So if Orion gets up nice and high, Lepus will be good underneath it.
Right there. Here we go.
There you go. There's Orion. There's the bunny underneath it. I always think of the rabbit on, what was it? The Holy Grail with Monty Python. Search for the Holy Grail. I don't know if you ever saw that movie or not, but they had a killer attack rabbit in it. And I always thought of Lepus as a killer attack rabbit out of Monty Python's Search for the Holy Grail. But anyhow, I don't know if you've seen that movie or not, but it is kind of funny.
Well, let's see. We've got a couple more. Do you want to talk about Algol?
Yeah, let's go for Algol.
Okay.
We've talked about it. When was it? The September last month?
Yes, we did.
It's called the Demon Star. It was part of the Clash of the Titans. It's usually represented as an eye in Medusa, the head that turns you into stone. And it's all, being a demon star, I figure that's good enough for Halloween. It's about 93 light years away in Perseus. And this is the first eclipsing binary star. It was, it's actually the second found variable star, but it's the first eclipsing binary star where you've got one star passing in front of another that's not very bright, and it causes the star to dim. And it turns out about every 59 hours, Algol dips from magnitude 2.1 down to 3.4 over about 5 hours, and then returns back up to magnitude 2.1 over the next 5 hours. And the variability of it was discovered by Germanio Montanari in 1667, and then in 1782, John Goodricke figured out how it was an eclipsing binary causing the change in brightness. And you've got a really good size, it's about 3 times the size, white-blue star. It's about 3 times the size of our sun. And then you've got like an orange subgiant star that's also about 3 times the size, but the blue one's about 100 times brighter, and the orange one's about 4 times brighter. So when the orange one passes in front of the blue one, we just happen to be along the line of sight, and it becomes dimmer then. But they're both really good-sized stars. And so
is this something you can see with binoculars? Can you see this?
It's actually a naked eye star. Algol's a naked eye star, but they're so close together, they're only like 20% the distance from the sun to Mercury. So they're extremely close. There's no way you could, split them even with, a Hubble or anything like that. I think they have to use a spectroscope and watch the lines go back, double up and go back and forth.
Okay.
And so other than recognizing, you could, there are some charts that you can get that show the brightness of the stars surrounding it. And you can sit down and judge it against the other stars and watch when it does a drop on brightness. And if you're patient, you'd have to stay out over 5 hours to watch it drop to a minimum. But a lot of people that are variable star observers like to do that sort of thing. And so that's the story about the demon star. Does that all make sense, Aurora?
Yeah. Okay, I think I've got it
graphic
here.
Yeah, you've got it there.
Yeah.
Also, I think called Beta Persei.
Let's see. All right.
Yeah,
do you
got
want
it there.
There you go. Do you want to do the last cluster since we're in Perseus?
Yeah. It turns out that this one's called the Perseus cluster. It's actually also the actual bright one in there is called Perseus A, which, you're circling it there, and that's the right one. That's NGC 1275, and it's got problems. Let's see, it's 2 degrees east and a half a degrees north of Algol. So it's not far from Algol. It's actually fairly close. And
let me just put it in so the program will circle it for us. Okay, go ahead. You keep talking.
Cool.
Oh. Sorry. Keep talking. Go ahead.
Okay, so we got about 2 degrees east and about a half a degree north. And you have that's the kind of like the dominant star in the cluster. The cluster is actually called A Bell 246 for Georgia Bell, that taught, I think, at UCLA as an astronomy professor. And he went looking for clusters of galaxies on the Palomar Sky Survey photos. And he found quite a few of them. But there's some interesting, that's a nice AOP, or I guess that's just the image in Stellarium, right? There you go. You got Algol and you've got the galaxy cluster.
Yeah, so we have Algol here, and this is where we're looking now, though. And if I highlight, you can see how many galaxies there are in here.
Oh yeah, there's a whole mess of galaxies in there.
Here's the Hubble picture of it.
That's probably a Hubble shot. You
can
see there's lots of little ones, little ellipticals. You've got those 2 big monster ellipticals in the center.
Yeah.
You got the little spirals all around the edges. And
this is the one you specifically were talking about, right, with this image?
Yeah, that one's very interesting. That's, that is hydrogen gas, but it's being held in filaments. And it kind of drove them nuts when they found it because they couldn't figure out what was going on. But what they think nowadays is there is a massive black hole in the center of that NGC 1275 galaxy, and there's a big magnetic field going right out of the galaxy, and it's trapping this hot hydrogen gas in filaments. It looks really bizarre. Definitely a Halloween type look there. But that was driving them crazy there for a while. Definitely a neat looking thing. And that galaxy is also called Perseus. And there you've got the X-ray. Yeah. This is centered about on the NGC 1275. And it's really, really hot gas. It's around 50 million degrees. It's, the image is in X-rays because that's what you get out of, extremely hot gas. You get the X-rays pouring out of it. And the interesting thing is this really hot gas, there's a lot of mass tied up into it. It's more massive than all those other galaxies we saw in this cluster. Oh, also that cluster is about 230 million light years away. So it's a long, long ways away.
Wow.
But I thought that was kind of a cool image to end the Devil's Dozen there for Halloween.
Deep Sky Dozen. I don't want to have nightmares. Well, thank you, Ken.
Maybe it's not a good Halloween unless you cause a few nightmares.
Well, there's actually a lot more in here that we just don't have time to cover. We covered the first 12 or 13, and then there's another of that many again in here for you to look at. You can look them up. Now you know about stellarium. You can go out there and try to find them with your telescope. Again, not all of these are up tonight, so you want to put them on your checklist for doing throughout the year, but these are Halloween-themed astronomy because, honestly, I really think that Halloween needs more like kids dressed up as Galileo and Newton to remind us of all the scientific discoveries we've been doing that require being out at night. So this was just something that both Kent and I wanted, and Brian as well. Thank you, Brian, for helping. He's the one who helped create this document, so putting things together, as well as Kent and myself. So, so Kent, did you have any other last closing words you wanted to let everybody know?
Just wanted to wish everyone a happy Halloween, and
stay happy.
I like the figure Brian put there on the handout. He did a good job for the first cut of the handout.
Yes.
It's a good handout.
Excellent. Well, thank you, everyone. Happy Halloween from us here at Central Coast Astronomical Society. We hope you have a wonderful Halloween. And now you can share the night skies with your neighbors and their kids and their families. Get people even more excited about the night sky. All right, we will see you soon. Take care, everybody.